Hello everyone. Today we are going to start a new topic, chapter 5. Name of this topic is Properties of Hardened Concrete. So, this is the outline of this chapter. So, let us discuss first what is hardened concrete. So, it is the concrete that must be sufficiently strong to withstand the structural and surface loads, and it must be durable enough for the environment risk for which it is designed. It is the strongest and durable construction material. And also we can say the testing of hardened concrete plays a vital role in controlling and confirming the quality of cement concrete works. Then let us discuss different properties of hardened concrete. The main properties, it is basically categories in three ways, like strength, dimensional stability and durability point of view. So, strength means also we can say strength, compressive strength, different types of strength are there, what we will discuss later. So, let us discuss first what is compressive strength. So, the strength of concrete is the one of the most important and useful properties of concrete. In most structural applications of concrete is employed primarily to resist compressive stresses. And this test is carried out on specimens cubical or cylindrical or prism in shape. Therefore, the concrete making properties of various ingredients of mix are usually measured in terms of compressive strength. So, again also we can say the cube which we generally used for measuring compressive strength are having the dimension 100 mm or 150 mm, and the cylinders are of 150 mm diameter and height of 300 mm. And the prisms used are 100 mm, 100 into 100 mm and 500 mm in size. So, the compressive strength given by different specimens for the same concrete mix are also different. The specimens are cast, cured and tested as per standard prescribed for such test. Due to compressive load or compression load, the cube or cylinder undergoes lateral expansion. And generally the strength of cylinder is normally taken as 0.8 times the strength of cube. So, what are the factors which affect the strength of cube and cylinder? Like concrete cube and cylinder casting, curing, testing procedures, geometry of the specimen, level of strength, direction of loading and machine characteristics, grading of aggregates. So, these are some main factors which affect the strength of cube and also strength of cylinder. So, if we compare between the strength of cube and cylinder, so for cube we can say cubes are cast in one direction, tested from other direction, but cylinders are cast and tested in same position. Also, in case of cube, in actual structures in field, the casting and loading is not similar to cube, but cylinder in actual structures in field, the casting and loading is similar to cylinder. Cube does not require any capping, but cylinder requires capping. So, these are some basic difference between the strength of cube and cylinder. Next is of stress-strain relationships of concrete. The stress-strain curve of concrete is a graphical representation of concrete behavior under load as shown in the figure. It is produced by plotting concrete compressed strain at various interval of concrete compressive loading or stress. It is mostly used in compression, that is why its compressive stress-strain curve is a major interest, and the relationship is linear in the initial stages but becomes non-linear, reaching a maximum value like this, and then a descending portion is obtained before concrete finally fails. The curve is usually obtained by testing a cylinder with a height to lateral dimension. So, this is the stress strain curve. Next is types of strength of hardened concrete. So, already one strength already we have discussed. One is compressive strength, next is tensile strength, shear strength, bond strength, impact strength, fatigue strength. So, these are some different types of strength which we can find in the hardened concrete. So, for testing or to know the quality properties of hardened concrete, there are some different types of testings are available or procedure are available, like basically it is divided into two categories. One is destructive testing, another one is non-destructive test, NDT test. First is destructive test. So, destructive testing of concrete samples involves applying direct stresses on representative concrete samples, after which these samples become destroyed. Variables that influence measured concrete compressive strength are like sampling, then next is casting, initial curing, also laboratory where we test, then curing, capping, testing, reporting. So, these are some factors which basically influence the measurement of compressive strength. Next is non-destructive testing. The standard method of evaluating the quality of concrete in buildings or structures is to test specimens cast simultaneously for compressive, flexural and tensile strengths. The main disadvantages are that results are not obtained immediately. Concrete in specimens may differ from that in the actual structure as a result of different curing and compaction conditions. Further strength properties of a concrete specimen depend on its size and shape. Therefore, several NDT of assessment have been developed. NDT means non-destructive testings are available. The non-destructive methods may be categorized like penetration test, rebound hammer test, pull-out techniques, dynamic test, radioactive test. So, these are some procedures which we can apply to measure or to continue non-destructive test of hardened concrete. Next is creep of concrete. It is the most important properties of hardened concrete. So, first is it is a time dependent deformation of concrete under permanent loads. So, when concrete is subjected to compressive loading, it deforms instantaneously. This immediate deformation is called instantaneous strain. Now, if the load is maintained for a considerable period of time, concrete undergoes additional deformation even without any increase of the load. If we do not increase the load, it also deform or it starts deformation. So, this time dependent strain or changes in hardened concrete is known as creep. And also we can say creep increases with increase in water cement ratio. Higher the modulus of elasticity, the creep must be less. Gradual increase in strain without increase in stress with time is due to creep. And we can say 75% of creep strain occur in 12 months, and the rate of creep decreases with time. So, creep takes place only under stress. This is the main cause of creep. Also, there are different factors which affect creep of concrete, like influence of aggregate, influence of mixed proportions, influence of age of concrete. So, these are some factors also we can say which affect creep. So, it has some bad effects on concrete, like in RCC beam, creep increases the deflection with time and may be a critical consideration in design. Next is shrinkage of concrete. So shrinkage of concrete is caused by the following causes like settlement of solids and the loss of free water from the plastic concrete, chemical composition, combination of cement with water, drying concrete, which is known as drying shrinkage. So we can say shrinkage are of three types. We can divide it: plastic shrinkage, autogenous shrinkage, drying shrinkage. So if we go for the definition, we can say it is the inherent property of concrete by which the volume of concrete is changed due to loss of moisture at different stages due to different reasons. So plastic shrinkage, let's see what is plastic shrinkage. This type of shrinkage itself shown after the concrete is placed in the forms while the concrete is still in plastic state. It occurs as a result of the loss of free water and the settlement of solids in the mix. Next is autogenous shrinkage. We can say as hydration continues in an environment where the water content is constant, such as inside a large mass of concrete, this decrease in volume of the cement paste results in shrinkage of the concrete. And the last is drying shrinkage. That means, so when a hardened concrete cured in water is allowed to dry, it first loses water from its voids and capillary pores and only starts to shrink during further drying when water is drawn out of its cement shell. This is known as drying shrinkage. So these are some different types of shrinkage. So for this lecture this much. In next lecture again we will continue this chapter. Thank you.